So in this video we'll be talking about dependency injection. We'll look at what it is and why you'll want to use it. And really, dependency injection is one of those amazing things that when you come across, you'll fall in love with it for sure. Dependency injection solves so many of the problems that you come up against when programming. Simply put, dependency injection is a way to decouple classes from what they depend on. It's a way of managing dependencies and reducing coupling between classes. So in our example, we're going to look at a CD player class, and obviously the job of a CD player is to play CDs. So let's have a look at what this might look like in the code. So we have a simple class here. It's a CD player. It has a property which stores the CD, and when we create the CD player, it creates a CD and stores it in the property. So this is a typical bit of code that you may find somewhere, and it's perfectly okay, but it does have some problems. And this is where we're going to start seeing how dependency injection really plays a part within programming. So what's wrong with this class? Well, first of all, this is like buying a CD player with the door shut, the CD tray glued shut with an existing CD inside. Because basically this CD player can only play the Beatles CD, and it can't be changed. There's no configurability. So this is a problem. What happens when you want to play another CD? Let's say an ABBA CD. So you may decide to modify your class something like this. So we've decided that the CD player constructor will take an argument, which is the name of a CD, for example, and we can perform some tests. If it's a Beatles CD, create a Beatles CD. If it's an ABBA CD, then create or use an ABBA CD, like so. This is also a perfectly decent bit of code. It's a way to solve a problem. But we're still stuck with the same issue. The CD player needs to specifically know about each kind of CD it's going to play. So you look here. In this case, the CD player has to know about the Beatles CD and how to create it. It has to know about the ABBA CD and how to create it. And the more CDs you add, the bigger your class is going to get. Each time you want to add a new CD, you have to modify your CD player class. This means your code is going to grow and grow and become unwieldy and potentially unmaintainable. And you also notice now that in order to solve the original problem, we've even had to change the interface. So potentially this creates backward compatibility issues because the CD player now requires an argument, which is the name of the CD. So how do you solve this? Well, of course you solve it with dependency injection. So the problem in our class is that the class itself has to know about the CD and it has the responsibility of creating the CD. So to solve it, we first of all remove the responsibility of creating the CD from the CD player, which is quite right. So this would be akin to, we're putting an opening door on the drive tray on the CD player where you can insert the CD like that. So how would that look like in the code? So something like this, where we create the CD outside of the CD class, the CD player class, and we insert the CD into the CD player constructor, like so. And so now the CD player receives a CD instance and it can store it and then later play it. So this is dependency injection. We are inserting a dependency into the class. We're injecting it. So there are two kinds of dependency injection. One is called constructor injection and the other is setter injection. This simply refers to how the dependency is injected into the class. So setter injection would look something like this, where you create a setter method which takes the dependency and we inject it like so into the class. You can see here creating a Beatles CD, we instantiate the CD player, and now we inject the CD like so. So now let's look at the benefits of dependency injection. So you can see very clearly that we're able to decouple classes from their dependencies, and we can therefore make our code more reusable and more readable. So let's look at what that really means. In the beginning here we have an unreusable piece of code. This CD player, works in this environment, but as we've said before, this CD player needs to know about the CDs it plays, which is a problem. So you couldn't necessarily copy and paste this into another project. In our dependency injection example, we have a nice piece of reusable code here. The CD player is a nice generic CD player. It just depends on having a CD. It doesn't matter what CD. It doesn't have to be a Beatles CD or an ABBA CD or anything like so. It just needs to be a CD. So this now is a very flexible, reusable piece of code. Dependency injection will solve something in larger projects or more complex classes. You may experience something called dependency carrying. We won't cover it, but dependency injection pretty much solves that. And very importantly, dependency injection makes unit testing of your code very easy. So the reason being is, as you know, in unit testing, the idea is to test things not as a fully functioning program, but you test the individual components. So in our first example here, the problem with testing this code here is when we create a CD player to test it, then it already has a Beatles CD stuck inside it, and we have no way of testing the behavior of the Beatles CD itself. Normally what you would do in unit testing is you would create a mock Beatles CD here, which you know how it behaves, and so you're able to then just test the CD player. Of course, in our dependency injection examples, we can simply inject a fake CD here, and we don't have to worry about it because we can force the behavior of the CD however we want it. Okay, testability. And when I say you also get the automatic ability to add new functionality, what I mean is that you can add new functionality without messing with your original class. So you think about it here, we can create, let's say, an ABBA CD like this, like this. We've created this is maybe a new piece of functionality, and we can just inject the damn thing into our CD player, and we've extended the functionality. So I think you can see now that dependency injection really has a lot of benefits to making your code more reusable, more flexible, less dependent on things, reducing responsibilities. I mean, the list goes on and on and on and on. So now that we've covered dependency injection, let's look at a slightly more advanced use of it. Dependency injection containers are basically a class which contains other classes. And rather than injecting individual classes, you would inject the container. So in our example here, we have a container which contains a whole bunch of CDs. And when we use that, we may inject the container here into the constructor. And what that means is that now that container may provide a whole bunch of services. It may provide a list of CDs, the most favoritely played CD, this kind of thing. And we can query the container itself. We can get back CDs, or we can get metadata information. So we won't be covering dependency injection containers in this particular presentation, but this is a precursor to the service manager, which is a very advanced dependency injection container, which you can read about or see in another video. Thank you very much for watching.